I'll begin this lesson with some quotes from Picasso. The first quote is as follows: "Art is the elimination of the unnecessary." And this sums up the reason I've been drawing from the abstract painters for inspiration for this part of the course on descriptive statistics. I believe the study of statistics mimics art in this way. Descriptive statistics eliminate the unnecessary. They provide spare, elegant, minimalist pictures of a dataset. And if the descriptive indices are chosen well, they provide the essence of the data. They can sum up a lot of information very quickly and very simply. I included these other two quotes mostly for fun. The first one is, "Computers are useless. They only give you answers." Now, this may or may not be an original Picasso quote. The point here is something that will have more meaning for you when you are further along in your path as a researcher. The key point is that answers are nice, but it is the rare and talented researcher who is able to come up with a really good question. Great questions are the key to great research. And finally, the last quote is here to provide encouragement. Keep working to master these statistical concepts. They provide some demanding challenges, but are well worth the effort. The quote is, "Inspiration exists, but it has to find us working. Inspiration will come if you keep working hard to understand the material." We'll continue the themes of the abstract artists, the idea that we can distill objects down to their simplest forms, that by selecting the correct tools for this summary, we gain information at the same time that we're losing information. So this is our last lesson in Chapter 4 on measures of central tendency, and we'll finish with some closing thoughts. This video will focus on Chapter 4.5, and these are closing thoughts on measures of central tendency. The topics for Chapter 4.5 are the relative placement of mean, median, and mode in skewed distributions, the limitations of central tendency, where the mean resides, and some alternative measures of central tendency. So, central tendency in a skewed right distribution, also called a positive skew or positive distribution, shows that the curve starts out looking like a normal curve, but then we have some outliers, some extreme scores at the high end of X. And what happens when we have this type of distribution is the mode and the median and the mean are separated, whereas with a regular normal distribution, the mean, the median, and the mode would be at the same place. But here we see the median is above the mode, higher than the mode, and the mean is even higher than the median because it's more impacted by the skewed distribution, by the extreme values in X, which we covered that in a prior lesson. And we see exactly the opposite when we have a central tendency in a skew left distribution, or it's also called a negative distribution or a negative skew. And here we see that it looks sort of normal on the right-hand side, but then it's pulled out, called skewed, on the low end, that there are some outlying values at the low end of X. And so here we see that the median is to the left of the mode, so it's a lower score than the mode, and the mean is even lower than the median, is even more impacted by the outliers at the low end of the distribution. So we're understanding that central tendency is not the whole story. All four of these distributions have the same mean. Mean here is 5, the mean here is 5, the mean here is 5, and the mean here is 5. But clearly the distributions are dramatically different than each other. That's why we need to understand another key property of the distribution. We need to know how the data are distributed relative to the mean. The second quality is called variability. Here are the means. We'll show that each distribution has the same mean, but they're very different looking distributions. I included this slide to drive home the idea that the mean must be a value that is within the range of the scores. That is, it must be greater than the lowest score and smaller than the highest score. The question, which of the following is not possible as a value for the mean, is a bit of a tricky one. The answer is that B and D are not possible because 82.44 is higher than the highest score in the distribution, 65, and 22 is not possible because it's lower than the lowest score in the distribution, which is 56. If we simply eyeball the data, we might say 61.77 is a possible value for the mean because it lies within the range of the dataset. However, if we actually take the time to conduct the calculation of the mean, we find 60.38 is the mean. Another measure of central tendency is the root mean square, and this is something we'll see again later in the course. It asks us to square each value of x, add them all up, and divide by n. Then take the square root of the total. You'll see later in the course how this index of central tendency can be helpful. Another measure of central tendency would be the truncated mean. The truncated mean is a procedural step rather than a mean based on a formula. There are times when it's useful to leave out the most extreme data points at the high and low ends of the distribution. Later in the course, we'll discuss situations that call for a truncated mean. For example, suppose you have a hypothesis about a set of variables, and you collect some data to test the hypothesis. You notice as you're looking at the pattern between the two variable distribution that there's support for your hypothesis. The data pattern is what you thought it would be. However, you also notice that there are a few people, maybe 4 or 5, who don't fit the pattern at all. These people are called outliers. Sometimes it makes sense to retest the hypothesis with these people deleted from the dataset. However, just because these people don't fit your hypothesis doesn't mean they're not important. I would take a closer look at the outliers and find out their story. Sometimes when we study the exception to the rule, we find deeper insight about our hypothesis. You might even want to follow up with these people with an interview and collect some qualitative information to understand their unique story. Another measure of central tendency is called the Windsorized mean, and it's a similar procedure to the truncated mean. Instead of removing the extreme values entirely, we simply change them to a more moderate value. For example, if you have a group of students with IQs ranging from 90 to 115, and there's one extremely high score of 145, there are situations where you may decide to change the extremely high value to a more moderate value of, say, 120. We'll discuss when and why you might want to Windsorize a mean in some situations. This is the end of Chapter 4, and up next is Chapter 5, where we will look at measures of variability.